Can your dead-end clamp survive years of harsh weather? These tests will show you what it's truly built for. Hey everyone, my name is Sahil, and in today's video, we will learn how to guarantee the quality of your dead-end clamp. By the end of this video, you will understand the electrical and mechanical tests required for these clamps, including the mechanical tests, the dielectric test, climatic aging test, corrosion test, and the endurance test. But why should you listen to me? At Axis, we've been manufacturing a wide range of AB cable fittings, including dead-end clamps for the last 30 years. Our accessories are approved in more than 50 utilities across India, Africa, and the globe. So, let's get into it. First, let's briefly discuss dead-end clamps and their usage. Also known as anchoring clamps or tension clamps, these components are used to strain the insulated neutral messenger in a low-voltage aerial bundle cable system. They help in providing tension and direction to the cable at angles and endpoints without damaging the insulation. To function properly, this dead-end clamp is installed along a bracket or other support hardware depending on the layout and design requirements. This makes it a customizable solution for different installation scenarios. However, to make reliable and long-lasting electrical connections, these clamps must be high quality. But how do you check that? How do you test it? In the rest of this video, we will walk through the 5 tests of dead-end clamps required by the NFC 33041-2013 standard. Number 1. The mechanical test. This checks if the clamp can hold the messenger wire under tension without slipping or breaking. So how do you conduct this test? Use an anchoring clamp and fix it to a neutral messenger cable of 54.6 or 70 mm square. Place the setup in a UTM machine. Now, apply the following load sequence. First, apply 4800 newtons of force, then release the load to 1200 newtons. Mark the messenger cable at the point where it exits the clamp. This marking helps measure any slippage with respect to the clamp. After that, apply a second load of 6000 newtons. Hold this load for 60 seconds, then remove it. The speed of load application must be controlled between 5000 and 7500 newtons per minute, as per the standard. If the clamp breaks, or if the cable slips more than 10 mm from the marked point, the sample fails. Secondly, the dielectric test. The purpose of this test is to check if your tension clamp can maintain insulation and resist electrical breakdown under high voltage. To perform this test, mount the tension clamp on an uninsulated conductor. The conductor must stick out at least 5 cm from each end of the clamp. Cap the ends of the conductor to avoid flashover. Earth all exposed conductive parts. Connect the high voltage source between the conductor and the conductive part of the clamp. Gradually increase the AC voltage at a rate of 1 kV per second until it reaches 6 kV. Maintain this voltage for 60 seconds. If flashover or breakdown occurs or the leakage current exceeds 10.5 milliamps, the sample fails. Thirdly, the climatic aging test. The goal of this test is to check if the clamp can withstand long-term exposure to temperature, moisture, and UV radiation without degrading. So how do you conduct this test? Install the clamp on the largest cross-section of insulated neutral messenger. Place the clamp inside a climatic chamber under accelerated environmental cycles that reproduce natural weathering. In the chamber, the sample goes through 6 weekly cycles at 70 degrees Celsius. The clamp is mounted such that the side of the cable entry faces the light sources. This setup ensures the insulated part is exposed to full UV radiation along with heat. After the aging period, test the clamp for dielectric performance and mechanical strength. What causes a failure? If there are any cracks, deformations, or surface damage, the sample fails. If the clamp fails the dielectric voltage test, or if it does not meet the tensile strength requirement, the sample also fails. If you're finding this video helpful, please subscribe to our channel for more insightful videos on electrical engineering. Fourthly, the corrosion test. The goal of this test is to check whether the clamp can resist corrosion caused by salt, moisture, and/or pollutants in the outdoor environment. So how do you conduct this test? Install 2 clamps on a neutral messenger 500 mm apart. Apply a load equal to 25% of the minimum breaking load between the clamps for 10 minutes. After that, place the samples horizontally in the corrosion chamber. The test runs for 4 cycles of 14 days. Each cycle includes 7 days of salt mist exposure, followed by 7 days in a sulfur dioxide atmosphere. After the exposure, remove the sample and check it. What causes a failure? If more than 10% of the metal surface shows red rust, the sample fails. If any marking on the clamp becomes illegible, the sample fails. If there's any damage that affects the clamp's function, or if the clamp fails to meet the mechanical load requirements after exposure, it fails. Number 5. The endurance test. The goal of this test is to confirm that the anchoring clamp can withstand repeated temperature changes and mechanical load without failing over time. How do you conduct this test? First, you fit the clamp onto both ends of an insulated neutral messenger cable, keeping a 2-meter distance between them. Place the setup in a test loop that runs 500 cycles. Each cycle lasts 90 minutes. Apply 10% of the minimum braking load as mechanical tension and mark the cable to observe any slippage. Follow this for each cycle. First 15 minutes, heat the messenger to 60 degrees Celsius by passing current. Next 30 minutes, maintain this temperature. Then the next 30 minutes, cool the assembly down to 25 degrees Celsius. The final 15 minutes, maintain 25 degrees to complete this cycle. Apply 25% of the minimum braking load during the first 75 minutes, then increase to 45% during the final 15 minutes. What causes a failure? If the clamp slips more than 4 mm after 2 cycles or more than 5 mm after 500 cycles, then the sample fails. Any crack, deformation, or insulation failure also leads to failure. After 500 cycles, the clamp must also pass the dielectric voltage test. I hope you now have a clear understanding of how anchoring clamps work and the rigorous quality tests they undergo. All the tests we discussed are performed at our Axiom lab in Mumbai, which is accredited by the National Accreditation Board for Testing and Calibration Laboratories (NABL) for ISO 17025:2017 and approved by Underwriters Laboratory UL. Before you move on to another video, remember that even the best tests can't compensate for inadequate installation. Watch this video to learn about the correct installation procedures for anchoring clamps.